homework go? Is it okay? It's 8. So obviously 8, 9, 10 have been ones we've been doing. So 8, 9, 10. Let's see. Can I paste it anywhere? Anything here to paste? Nope, that's not what I wanted. I'll do that. All right. So 8, 9, and 10. Okay, so 8, 9, and 10, how they're written, they don't have their asymptote is this. Agree? And so the first problem, doing blue, we got f at x, which means the same thing as y equals. It's just a fancier way of doing it. 3 raised to the x. So if I plug 0 in, I get 1. So 0, 1's here. Then if I plug 1 in, I get 3 to the first, which is 3. So it look like that. Domain of all these is negative to positive infinity. The range on this one starts at the yellow 0 and goes to infinity because it goes upward. Okay, now let me finish these. And one thing I wanted to talk to you guys about. So I get this is my equation. So if I plug 0 in, the gotcha on this one, if you plug 0 into this, you wind up getting negative 1. Okay? Because that negative 2 is not in parentheses. And then if I plug 1 in, I get 2 to the first. So that would give me negative 2, so 1 comma negative 2. And then the third one is h at x. Again, fancy way of saying y. So if I plug 0 in, I get 1. And if I plug 1 in, I get 1/2 because 1/2 to the first is just 1/2. Okay. Now there's a term that I want to say, and it's relatively easy. If you use stirrup lingo, it's easy to do. So this is called a growth. This is called a growth. And this is called a decay. Okay? Now, how these work is this way. Keith, put your phone away. Okay. Ready? In order to determine growth and growth, they're both growth. As I go to the right, my graph is going away from my line. Okay, my asymptote. As I go to the right, so as I go to the right this way on this one, this is going this way away from it, so it's growth. As I go to the right here, as this goes away from it, so it's growth. Decay means as I go to the right, I get close to my asymptote. So you have 2 growths and 1 decay. Okay, so that might be something to kind of get in your head. As I go to the right, do I go away from my asymptote? If that's the case, it's growth. Do I come close to my asymptote? And then it's decay. That's just a little piece of information about each of those. Okay, and then I also have to do the domain on this. Number 9 is negative to positive infinity. My range comes from negative infinity and goes to 0. My domain on this one, negative to positive infinity. My range goes from 0 to infinity because as you progress up. Okay? Any questions on those? So, what did we do? What did we do to move that yellow asymptote up or down? What takes place with the problem? What moves that yellow asymptote up or down? Yeah, if I add or subtract at the very end, so number 11 and number 12 will have that kind of thing in there. So I just put both of those. So number 11, we have f at x equals negative 6, 1/2 raised to the x plus 3. So what's my asymptote on this one? 3. Okay, so this right here, I'm going to go up 1, 2, 3. There's my asymptote. Okay, does that make sense? So that means that any of the math that we do, we make sure we have to add 3 to it. So if I wanted to get my 0 value, that's going to be -6 plus 3. -6 plus 3 is -3. So 0, -3. It's down here. If I plug 1 in, I get 1/2 to the first. It's 1/2. Half of -6 is -3. -3 plus 3 is 0. So this is going to look like this. So by what we said before, as I go to the right, is this growth or decay? Decay. As I go to the right, it gets close to my asymptote. So this is a decay model. Okay? My domain will be negative to positive infinity. My range is from negative infinity up to whatever the asymptote, which is 3. Make sense? Then I have one here. This is g at x is equal to 2 raised to the x minus 4. What is my asymptote on this one going to be? -4. So I'm going to go down 1, 2, 3, 4. There's my asymptote. Okay. Now we can start plugging values in. If I plug 0 in, 2 to the 0 is 1. 1 minus 4 is -3. So it's down here. If I plug 1 in, 2 to the first is 2. 2 minus 4 is -2. So this is going to look something like this. If I look at that graph, as I go to the right, what is it doing with the pink line? Is it going away to it or is it coming to it? Is it going away? So it's a what? Growth or decay? Growth. Good. And then my domain, negative to positive infinity. Range goes from -4, whatever my asymptote is, to infinity. And that, my friends, is how you do those. Okay? All right. I'm going to give you a packet, and this packet is not due on Monday. This would be probably next, today and Monday as well. Maybe also have Tuesday in there. So please do not lose this. If you lose it, you got to write down your own. Okay, this is going back to reviewing. So hopefully you're hanging on to your review pages. One, 2, 3, 4. Oh, someone didn't pass their papers back, so there's a certain row, won't mention any rows. Need one? Oh, hello. Everybody can get one. Supposed to pass you one. Oh. Oh. Everyone got one now? All right, so we're looking at this front page, and we've already done these notes, but we'll just kind of review them, make sure you feel good. There's a way when you have two equations given. There was a couple of methods we went through, but we'll just go through basically two of them, one today and then one Monday, and we'll finish them up. So the first example, they give us this equation. So these are two lines. that I think they would cross. Okay, so we want to solve what the x and the y value would be. So friends, on this first one, is there a value, x or y, that you can guarantee the answer would be? 5. Good. So I definitely know one of the answers. So what I'm going to do with that 5 is I'm going to take this 5 and I'm going to replace it here. So I'm going to bring this equation down. So I get 3x plus, there was a y there, but now I'm going to put a 5, is equal to 2. What should I do to that green to solve it? Subtract 5. Very good. Those cancel, so I get 3x is equal to -3. Last step, divide each side by 3. Good. So -3 over +3 is -1. So if I had graphed these two equations, that's the exact point they would cross each other. If I took those x and y values and plugged it into both the equations, I would wind up getting true statements. So if I plugged it into the top one, the 3x plus y equals 2. If I plug the -1 in for x, I plug the 5 in for y, my answer would result in me in 2 equals 2, which is true. On the second equation, you can only plug the y value in, so you'd wind up getting 5 equals 5. Okay, but that's how you would walk through that kind of problem. So substitution is where you take something from one equation and you replace it for the other equation. You remember seeing this earlier this semester? I hope. At least one of you. All right. Now the second equation, we have this. We have y minus 3x is equal to 7. And then we have x equals y minus 1. So remember, I'm looking for an x and a y value. Do either of those equations say this is what number x is equal to, or this is what y is equal to as far as numbers go? No, I can't see it yet. Okay? So what I'm going to do is I have to pick one of the equations. Hopefully we find an equation that we have x or y equals already. So I'm going to take this here, and I'm going to replace it with this x, because x is equal to that. I'm going to go in place of it. Does that make sense? All right, so now I'm going to get y minus 3, put some parentheses, equals 7. Where those parentheses are is where x used to live. But now we got someone new moving in. We have y minus 1 moving in. So this came right here. And then we have to remember when we distribute, I'm distributing a -3 over the parentheses. These are like terms, so that gives me -2y plus 3 is equal to 7. Okay, what should I do next to get y by itself? -3, cool. So that's going to give me -2y is equal to 4. What should I do to get y all by itself? Divide by -2, very good. Those cancel. So 4 over -2 is -2. So my y value is -2. Okay? Now we have a choice to make. I know I have this, that y value. So I could plug it in here, or I could plug it in here. Which one seems a little easier to plug it into? The bottom one. Very good. Because I'm looking for an x value. Okay, so I'm going to take this. I'm going to go x equals -2 minus 1. And -2 minus 1 is -3. That's my solution to that problem. Okay? All right. So on the back side, I would like you to give you the opportunity to work on problems. Well, let's just do this. Let's go to problem number 1. We'll do it together. Okay, that's good. All right, this is problem number 1 on the back. Agree? All right, so I'm trying to figure out an x and a y value to plug it into. Agree? They're both y equals. Okay? So what I can do is I'm going to take one of the equations and replace it with the y on the other one. So then I'm going to wind up with 2x plus 1 equals x plus 1. Okay, we can go ahead and start solving that. So perhaps we might subtract x from both sides. So those are going to cancel. And perhaps we're going to subtract 1 from both sides. So those are going to cancel. So if I take care of this math here, I'm going to get x equals 1 minus 1 is 0. So I get a 0 there. All right. So now I know x is equal to 0. So I can plug it into either of them. Top or bottom. It's going to be the same answer no matter which one you picked. Okay, so maybe I'll plug it in the top one. It was x plus 1. Now it's going to be 0 plus 1. So I get 0, comma 1. That's my solution. Do you feel comfortable with that problem? Let's take a look at number 3. You with me so far? Can I move on? Problem number 3, we get x minus 2y is equal to negative 6, and we get 3x plus 5y is equal to 26. Okay? I'm going to modify this top equation to look like this, and you tell me what I did to get there. What did I do to get to the green from the purple?
You just subtracted y.
Yeah, I moved the y over, so I went plus 2y plus 2y. Okay? So by doing that, so now what I'm going to do is I'm going to say, I want to take this, and in my other equation, I'm going to replace the x with 2y minus 6. So I'm going to get 3 parentheses plus 5y equals 26. That had been an x, but now I'm going to put 2y minus 6 in. Okay, do the math. So I get 6y minus 18 plus 5y equals 26. Those are like terms, so we can add them together. And then I'm going to add 18 to both sides. Those cancel, so I get 11y equals, oops, that's an 18, equals 44. Divide each side by 11. So y is equal to 4. So I get a 4 right there. I now need to take this 4, which is a y value, and plug it into either of them. Doesn't matter which one you plug it into. Still going to be the same exact answer. So perhaps I'll plug it into the top one. So let's bring this. I have x minus 2 times 4, that was a y, equals negative 6. X minus 8 equals negative 6. Add 8 to both sides. So x equals 2. So my solution to this problem is 2, comma 4. You guys walk in Monday, I'll probably rearrange the room again. Stirrup's crazy. I don't know. I think it's kind of cool. Now you get 2 different boards to look at. I don't think anyone can say I can't see a board. Huh? Huh? Here? I've thought about that.
This one's good because I'm going to trade again.
Well, if I bring that over here, that means I'm going to teach from over there. And I kind of like teaching here because I like keeping an eye on the hallway, make sure nothing dangerous gets in. Someone dangerous comes in, I'm ducking behind Sebastian. Like, I see how you roll. You guys know that big desk right there, there's a reason I have it close to the door. If we ever had a bad situation, yeah, I'm going to grab grab a couple of you. We're going to turn that desk onto its end so it's standing tall. The door will be locked, and we're going to shove that into where the door is as well. And then we're going to take all these desks and barricade behind that. And then we can unplug that and then push that over there. And I kid you not, in that closet back there, if we were barricaded in here for a long period of time, something's going to be taking place. Someone might have to go potty. I got that white bucket and the other white bucket that's in there, that becomes the restroom. I kid you not. I've already thought of this. Yeah. We'll make that become a small facility. Looking out for us. Kind of preparing. Hopefully we never have to utilize it, but just in case, I've kind of... Which is fortunate, but it's also unfortunate.
Yeah.
So that's why we're going to barricade the living you know what out of this.
That's why.
No, but I feel like it's not safe, because what if you have to, like, get out there?
Oh, I'm pretty sure we could push that desk aside if we needed to.
But then what about the board and then the other desks?
If it got to a point, I bet you we could get stuff out of the way. I mean, my main concern is that if someone coming through that door, if they open it going, oh, dude, there's a 250-pound desk in the way. That's solid oak. Maybe they would change their mind and move on. And hopefully then the good guys would catch the bad guys. But I'm just trying to give us some thought.
Yeah, we're kind of like a corner
We're also like
the
in
bottom
the back
level.
of the school.
Yeah.
They just come in and target us.
Oh, I hope not. But I want to prepare as best we can.
We are like tucked away.
I would have this military man.
Take it. I like it. All right. So I feel that you can do problems 2, 4, 5, 6, 7, and 8 on just that sheet only. And you can work on that for Monday.